This video file was recorded in Sabunja University during recitations for the CS204 Advanced Programming course as it was given in the spring semester of 2017.
Good afternoon again. We are here after the term break and after the midterm exam for the 9th week. Let's not waste our time and let's start with new examples for today. We're going to learn 3 new stuff. We're going to cover 3 new topics today, namely iterators, templated classes and functions, and shared objects. We will see 3 examples for all of them. Now please download your codes and just copy-paste all the codes from today to your solution folder. And we are going to add them as we need them. So copy after extracting your folder, copy paste it to your solution folder. Okay. Now let's start with the first example. Namely, we are going to see the iterator. So you see the LinkedListIterator folder, just open it, copy paste. No, don't copy paste anything, just add them from the menu here, existing items. Go with the LinkedListIterator and add everything here. Now before covering this example, let me first tell you what are we going to do. You remember the linked lists, namely the doubly-linked lists. Just let me remind you. So this was how a doubly-linked list looked like. Okay? So we had the right and the left pointer. Usually the right pointer was called next. The left one was called previous. You can name it as you want. And usually we have one or more data field here where we keep our data. Very often we should iterate. Iterate means go through this node, this linked list, to all of these nodes of this doubly linked list, and do something with the info data there, or maybe the pointers even, like process them, print them, change their values, and so on. So very often programmers just want to deal with this kind of important stuff, processing the data info here inside those. It might be strings or whatever, like let's say CS204 blah blah or whatever. So they want to process this data here, and they don't want to deal with moving and going through those pointers. They want to give this job to another class, which we call iterator, and the job of that class is to go through those nodes. Namely, we can say, okay, go to the next pointer. It's very easy in this case, but I'll tell you an example when it's hard. Next, if we are pointing at this node, it's very easy to go to the next node. We just say, this node next. If we want to go to the previous, we go to the previous. Sometimes we want to give orders like this, go to the end. Yeah, it's easy doable. While the next pointer is not null, we go to the end. Or we can say go to the beginning. If we are somewhere in between or even in the end, if we want to go to the beginning, we check whether the previous node, the pointer to which this point, to which the current pointer is pointing, previous pointer. If it's not null, then we just go and iterate it. So this is very easy. But however, we have examples like this. We have data structures like this one. This is also a data structures. A data structure. Here we have the right and the left pointer. For the guys that are going to take the algorithms course, will know that this is a binary tree. Okay? Maybe you have seen it before. So we have also left, next and previous pointer, which here usually are called right and left. And we have some data here. And when we are going to iterate through these data structures, it's much more harder to go to the next, to the previous, to the end, to the beginning. What do I mean? First, should define what we mean by the next, by the previous. Let's say that I want to go through the left node. So this is the left, this is the right node. Then O means the center node, and then the right. Always remember this. So I start from here. Do I have left node? Yes, I go here. Do I have left node? Yes, I go here. So this is number 1. Afterwards, I go to the center one. I go here, then number 2. Then I go to the right one. I go to the right one. But this right has another left. So I go left, center, right. Okay, if you want, I can write it C, meaning center. So this is number 3. This is number 4. This is number 5. Then I finish, I go here. The left side of this node is finished. So I write 6 here. Then I go here. Okay, this is center node. I have left node here. That's why I write 7, 8, 9. Okay? So when I'm going to iterate it, go through it, I should pass them like this. And this is much harder. From here, and those are, by the way, pointers. Left and right are pointers, just like those pointers. Actually, you can assume that this node here is the same as this one, but the logic to which the data structure is arranged is kind of different, very different. This is linked list, doubly linked list, this is binary tree. Now, it's not straightforward, it's not that easy to go to the first node to the last node. If we are here, or if we are, let's say, here, what is going to be the next node? The next node is going to be this one, if you use this notation, left, center, right. Okay? And this is pretty hard to program. That's why programmers want to give this task to another class, which is called iterator. And they program this iterator class so they can go to the next node, to the previous node, to the first node, to the last node. So if I'm here, what will be the next node? It will be 3. If I'm here at 3, what is the previous node? It's 2. Okay, if I'm using this LCR notation. You might ask, why do we need this stuff? Well, what if instead of the numbers, we had operations here? Let's say I have multiplication here, subtraction here, addition, again addition here. Some calculators work this way. First I execute this stuff here. 3 multiplied by 5 is 15. So I'm going to erase this stuff and I'm going to put 15 here. Then 1 added by 15 is 16. So instead of this plus here, I'm going to have 16. Then 7 minus 9 is minus 2. So I'll have minus 2 here. And 6 plus minus 2 is going to be 14. So I have 14 in the end. Some calculators work this way. Of course, this is too advanced example. You don't need that, but I'm just going to tell you why we need something that we are going to see, which is called iterator, namely to go through or iterate through a data structure. Of course, this is easy to be done. That's why we are going to cover this easy example. And afterwards, maybe if you become a programmer or doing your senior years here, you might do some iterator stuff with more complex data structures. Let me see first the output of this guy here. Let's see what we are doing here. And let's see how we have done it. So, let me enlarge the font also. We're asking for a number of elements, namely 5. This is actually the number of nodes that our doubly linked list will have. We will have 5 nodes. Now I'm going to enter all of them. Let's say I'm saying CS204 is this is the 3rd element, this is the 4th, awesome course. And then I print them somehow. I add new elements, I change part of it, and we are going to see how do we do that. Namely, we know how to do it, but how we are going to use the iterator class to go through this node, to the next, previous, to the beginning, to the end. Okay? So I don't want to bother with iterating. I just say to that class, okay, go to the end, go to the next node. If I have a next node, it will go. If I don't have a next node, it will say, sorry, you are in the end. First, let's go with something that we have seen already. Let's go with my list class. I'm going to erase this stuff here because we don't need it for the time being. We're going to redraw it as we go through the code. Okay, myList class is basically the class where we keep the pointers, the head and the tail, for our doubly linked list. Okay, the head points to the first node, the tail points to the last node. And of course, we have other functions like addToEnd, addToBeginning, number of elements, where we add in the end the node, and we add to the beginning, and so on. So let me write this class first. Let me see how it looks like. So this is class myList. We have private data here. We have the node class. We have put it to be as a private member. We can do it. And I don't have to explain the node class. Namely, we have this kind of node, doubly linked list node, as we saw it previously. We had next, we have a pointer to the next, to the previous node. And we have, this is important, a reference called data of type string. Okay? So this is a reference. And of course, we have the constructor. We take string D, a reference to a string D, node N, pointer to a node N, pointer to a node P, and we set them correspondingly. Now let's see what do we, so node is part of this guy. What do we have as private data here? Else, we have the head. Let me write the head here. And this head is a pointer to a linked list. It points to the head. Also, we have the tail. And this tail is also a pointer, so you can see, to a node, which is the end of the linked list, doubly linked list. Okay, and of course we had here defined the class node. Is this all for private? Yes, except for we have something friend. You remember friend functions. We have a friend class which is called myListIterator. And can you tell me what are the most important properties of the friend classes? So this is friend, myListIterator. This is it. What do friend classes do? Exactly. Friend classes or friend functions can access the private data. Namely, this myListIterator can see the head and the tail of any object of the class myList. This is all for the private part. Now let's go with the public part. Let's see, what do we have there? Public, well, we have the constructor myList. What else? We have another constructor myList with some parameters there. But remember, we take here, pointer to a string, which is an array. And this array will be used to fill the linked list. We have the function called addToEnd. And it's obvious what it is doing. We have another function called addToBeginning. And number of elements. I forgot to tell you that as part of another member variable, private variable, is this number of items. Here we keep the number of nodes of our doubly linked lists. So number of items is also an integer, basically, where we keep the number of elements of the nodes in our linked list. Now let's go and see their implementation, corresponding implementation in the corresponding CPP file. So the constructor does nothing else but puts this head to a null, the tail to the null, and number of items is 0. This guy is 0. We don't have any node, everything is null. Very simple. Now let's go to the let's go to the addToEnd function. It's obvious what we are doing here. We add an element to the end, meaning that we add an element here. If the tail, so if we add, that means the tail is going to be changed. The tail is going to point to the newly added node. If the tail is null, meaning that we didn't have any element previously, and if the tail is null, that means that the head is null also. But what we are doing is the following. We declare a new temp pointer, which points to a newly allocated node with this stuff, new data, and new data is taken as a reference. This is very important. Everything is reference here. It points, the previous node points to null, the next node also points to null. So basically this is what we're doing with the first line of code. We put the data here, let's say CS, previous node points to null, next node points to null, previous node points to null. Then I'm saying tail is equal to temp. So temp was this stuff here. Temp is this node here, and I'm saying tail is pointing to this node. But also head is pointing to tail, meaning head is pointing here. Okay? Now if I want to add another node, and if the tail is not empty, I'm calling this function again, and I'm checking if tail is equal to null, but it's not null. That's why I go here. I again create a new temp. So with this part of code, new node, new data, null, tail, this is what I'm going to do. I'm creating a new node. The data is here, let's say is. Then the next node points to null. This pointer points to null. The previous pointer points to tail. Okay? So the previous pointer is pointing here to this guy. And then I'm saying that tail next is equal to temp. So this is tail. Tail next is this stuff. This guy should point here. And then I'm saying that tail is equal to temp. So the newly added node will be this one. Tail is going to point here. And as you see, the next node of this guy points here. The previous node of this guy points here. So we are creating a linked list. This is addToEnd. So we saw my list. We also saw addToEnd. Now let's go and see. No, this was addToEnd. Yeah. Let's go and see the constructor. What do we do with that constructor, the second constructor? This constructor takes an array of string, and here we have the number of elements in that array. So basically, if we don't have this stuff here, if initially everything is null, that's why this is the constructor, the first function that is called when we create a node. We have this array here. And here, let's say we have CS204 is an awesome course. Okay? We have 5 elements here. When we call this function, initially we set the head to be null, tail null. Number of items initially 0. But when we add, when we iterate all of the elements from 0 to the number, and we had to end those elements. So we start from here. We had to end CS204. Basically, we have something like this initially. Then we go with the next node. We add it here using the addToEnd function that we already saw. But as we do this, the data that is put here, if you remember from addToEnd, addToEnd is using a reference. So this is very important. So here I have a reference to CS204. Okay? Here I have a reference to is. Then I have a reference to an. These are not pointers, those are reference, and so on. Basically, I'm going to have 5 nodes. 1, 2, 3, 4. 1 more, 5. And this is how this is going to look like. Head is going to point to this guy, tail to this guy. This is null, and we have a reference to the course. Okay, everything basically here is reference. So if I change this array here, those changes will be visible here, and we will see it through the code. So we saw the myList constructor. Is everything clear up until now? Yes? This array will help us to build the linked list. Okay? This is it. Because when you enter the data, okay, you keep them in the array, and afterwards you can add some other data in the end, at the beginning, which are not related to the array. Okay, this is like kind of, how can I say it? It's like, okay, why I'm having, when I call the constructor, I'm giving as a parameter an integer, when I can keep the integer. Okay, you use that to create an object, okay? You don't want it to be empty, to point to head, to null, head and tail, okay? You want them to have some nodes. Yes?
It said addToEnd, but didn't we add to the beginning? Like, event like this?
Yes, we are adding them to end. This is how it works. This is what I didn't write that code.
Yeah.
I'm just explaining. We're not adding them to the beginning. I'm adding them to the end. So this element is added here. And oh, you're right. You're right, I'm sorry. When I add, yes, you're right. Nice remark. So we add here, okay, you're right. So we add here, this is CS204. Okay, we add to end, that means that the second element is added here. Yes. So this is a reference to this guy. This is a reference to this guy, and so on. You're right about that. Okay. Thank you for your remark. So this is all for the constructor. Any other question? No? Let's go with the function addToBeginning. It's straightforward. It's doing the same thing, but in opposite way, in a sense, of what addToEnd was doing. Here we add a node to the beginning. So we've had this now. We add a new node, and the head and tail point to that node. Otherwise, we had a new node. So head previous is ptr, and head points to that. Basically, if I add a new node, I create that node. I make the next pointer point to the head, and then I make head previous point to the newly created node, and I make head point to the node itself. Okay? I think I don't have to go and explain it furthermore. So this is addToBeginning function. A number of elements, of course, is returning the number of items. So this is my list class. It's something that we have already seen. The new stuff here is the following. And please pay attention. If you don't understand something, ask. Let's go with the header. You remember this friend class here, myListIterator? Well, this iterator will help us to iterate, to go through this linked list. And it's a friend, meaning that it can see the private data, the pointers and the data inside the nodes. So we defined a new class, which is called myListIterator. Let's see what does it have as private members first. This is interesting. As a private member, it has myList, constant myList, reference to that, which is called list. Okay? Constant means that we cannot change. So we have variable called list, which is of class myList, the one that we just defined, and it's a constant, meaning that we cannot change anything about it. Okay? Directly. Directly, yes. Indirectly, of course, we can do it. And we take it as a reference. Basically, you can think that it's a kind of included inside my list iterator. We also have a pointer to a node, but since we defined the node inside the mylist class, we have to use it mylist double points, 2 points, 2 points, star current. Okay, so how does it look like? It's a bit weird, I might say. That's why I'm going to draw it here. Okay, so this is my class, my list iterator. I don't have to go till the end. It has a reference to a list. You might think the list is included inside, although it's not. It's a reference, but you might assume it's inside. I am going to write the name of this guy is going to be list. So this is the list inside of my list iterator class. So this is class my list iterator. Okay, what else do we have here? We have a pointer to a current. We pointer to a node which is called current. So I'm going to write the pointer. The name of the pointer is current. And it's a pointer just like the head and the tail is inside the mylist class. Okay? So the object of the mylist class here is called list. You can give it any name you want. What are we going to do? This current is going to point to one of those nodes here. Okay? And we are going to keep the current node, current pointer here. If I want to change it, I just say current is equal to next or previous or beginning or end. We are going to see it with the codes here. But first, so this is about the private stuff. And I'm finished with the private stuff. So this is private. This is all about the private data. Now let me go with the public data. What do we have here? We have the constructor. And as you can see, the constructor as a parameter takes a reference, which is called L to my list. Basically, it takes this guy as a parameter. So my list iterator, this is our constructor. Then we have next, which is self-explanatory, basically. You might assume what it is doing. Data, and it returns a string. So can you tell me what is this guy going to do, this function? You have idea or not? Okay, just let me write it. That it returns a reference to a string, and the name of the function is data. We have previous, go to end. So we have previous. We have the function go to end. And we have the function go to beginning. Okay? The final function, public function, is has more. Now let's see what are those doing. Let's go with the constructor first. Everything is defined here. So, when I take the pointer, when I take the reference to my list, I make this guy, which is called list, all of this class, to be actually this L here. This is how I said it, list L. Okay? I'm creating it. And I'm making the current pointer to point to null. And it's pointing to null. This is what the constructor is doing. When I use the next function, what I'm doing here, I'm saying current is equal to current next. But before doing this stuff, let me go to, let's say, go to the beginning function. So we just saw the constructor. Now let's go to the goToBeginning function. Let's see what it's doing. What it is doing. Current is equal to list point head. So where's the list now? List is this guy here. List head is this guy, this pointer. And I'm saying that current is equal to list point head, which is a pointer. Basically what I'm doing is that I'm making this pointer to point to the head. They're pointing to the same data. Now, this is head is the private data of list. Can I access it or no? Isn't this a strange stuff? I can access a private data of a class. It's a friend class. That's why I put LinkedListIterator to be a friend class, so it can see the head, the tail, and number of items. Okay? So I can do it. This was goToBeginning. goToEnd is saying current is equal to list point tail. List is this guy here, and tail points to the end. So I'm going automatically to the end. Okay? So this is the goToEnd function. Now if I'm in the beginning, and if I want to go to the previous node, how do I do that? Well, if I want to go to the next node, this is how I do it. So let's say current was pointing here to the beginning, and I want to go to the next node. Very easy. Current is equal to current next. So this pointer now is pointing here. Okay? If I say next again, it's pointing here. Pay attention. This list here, doubly-linked list, is not part neither of the myList class nor of the myIterator class. It's outside. Okay? Meaning, if you can do some tricks, some hacking stuff, you can access this data. But in order to access this data, you should know the head or at least the tail pointer. Otherwise, you cannot access it. You cannot guess the number of pointers. It's like guessing to find the home of someone in Istanbul. You cannot do it. All right, so this is about the next, let's say the previous function. Straightforward. Current is equal to current previous. So if we were here, if we call the previous function, then current is pointing to the previous node. Okay? So it's pointing here, basically. Now you remember the function data, what it is doing. It's returning the info value to which the current pointer is pointing. Okay, so current data, and data is here, is returning the info value of this stuff. Okay, and then it is returning it as a reference. So everything is a reference. Meaning if I change this guy, I change this guy also. If I change this, I change this, because this guy is actually this one here. Everything is as a reference. So we made up this example in order to tell you how iterators work and also references, because we're going to use this in our later example. We will see it. We will see a game actually. So we saw the data function and also has more. Has more actually. If the current pointer is pointing to null, has more returns true. False actually. It is pointing to something else, it's returning true. So if the current is not null, return false, otherwise return true. Basically, how do I get null pointer? If I'm here and I go next, 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 eventually I come to this null pointer. Okay? So this current will point to this null pointer, and I'm asking, are there more elements in our list? And in order to do this, I'm going to use the hasMore function. If the current node points to null, then hasMore is returning false. Otherwise, it returns true. So this is it about iterators. Now, if we want to go and iterate through this list, we are going to use those functions from the MyListIterator. Next, previous, goToEnd, goToBeginning, has more to see whether we have elements, nodes, or not. And if we want to return the data here, we use this function here. This is it. We don't do anything else. Is this hard or no? Did you understand this? How many of you? Raise your hand. Okay, very nice. Any question? No? If this is the case, now let's see a concrete implementation of this class in main. So, this is our main function. What I'm doing here, I'll start with this part first. And then we'll go with the functions. Okay, so in main I define number of elements, which is the number of elements I'm going to have in my array, which is called data list. I'm entering the number of elements, reading it, and I'm creating a new array with number of elements. Let's say if I enter 5, then I'm going to create an array like this. And afterwards, with this for loop, I enter the elements and I put them to this array in the corresponding places. So let's say I created the data list array, and this is the data list array. So this is the data list, and these are the indexes 0, 1 till 4, because I've entered 5, and I entered all of data up until now. Afterwards, I create my list, which takes data list as a parameter and number of elements. If you remember my list, this was my list. It had a constructor. This constructor took an array and the number of elements of that array, which is this one, and we are adding those elements in the beginning, which your friend pointed, okay? So this constructor basically, so your friend asked why we need array, because we want to put this data here and we can iterate those with the iterator without touching the array. So with my list, we basically create exactly this picture, okay? We add nodes to the beginning, to the end actually, as it is shown here. And those are references to the strings, because this was how the MyList constructor was defined. Now I print the list in forward and backward manner. And what are forward and backward doing? Let's go to the functions forward and backward. The function forward takes a reference to a list, so everything here is reference. And I'm creating here, declaring a new list iterator, which is called itr. And you remember the iterator took a parameter, as a parameter, the constructor of the iterator takes an object of the class MyList. In this case, this is it. So I'm creating an iterator. Basically with this stuff, I created this part here. Okay? And the list is LST is this guy here. Now I'm printing the list. And how do I print it? I go to the beginning. In order to go to the beginning, I'm using goToBeginning function. So I'm saying iterator point goToBeginning. When I do this stuff, automatically this guy current points to the first node. Okay? And I say, while iterator has more, okay? Meaning if I have data here, if the current is not null, then what I'm doing, I'm printing the data to which iterator is pointing. I'm printing this data. And then I'm making the current pointer to go to the next node using next. Okay? Using this function here, basically. Where is next? This one. So iterator points here, I'm printing it. Do we have data? Yes. Go to the next, print it up until we go to null. When we go to null, this current points to null. So has more this guy will be false. We go outside, we print to analyze, this is it. We have another function. So the name of this function was print forward. We start from the first element, we go up until the end. Similarly, in the same fashion, we have the print backward function. I start from the end and print the nodes one by one. How do I do that? In same fashion, printing the list in reverse order, I print it. Of course, I declare a new LinkedListIterator, which takes the list as parameter, blah, blah, blah. And previously, remember, I went to the end. Now I go to I went to the beginning, previously, the previous function. I go to the end. Basically, this current guy points here. Now, while I have more elements, I print the data and I go to the previous. So it was pointing to this one, then it points here, printing it. Do I have more? Yes, go. And so on, up until the end. This is it. I have another function, the last function that we are going to use in this example, which is called setFirstCharacter. Basically, here I take my list as a parameter, which is called list, and the character, and make each of those data of each of the nodes, I change the first character only. So let's say if I put 0, if this character is 0 or A or whatever, everything here is going to be changed. But hey, those guys are those guys actually. So if I change those guys, if instead of C, if I put 0, I'm going to have 0 CS204, 0 S, 0 N, awesome, awesome, OO course. Okay? This is how I do it. Again, I declare a new iterator, I go to the beginning. While I have more, in temp, this is a string, where I take the data of the current iterator, and then I say iterator, so I take the data and I say iterator data is equal to this character, I'm setting the first character, plus the substring from the first till the end of the string, okay? Basically, what I'm doing here, I put the first character and CS204 here, so it will be 0S204. This is what I'm doing. And then I go to the next node. Again here, I take this S, I put 0, then the other S, and so on, okay? Do you get what I'm trying to say? Now, can you tell me this data actually was returning a function, was returning a value? How can I set that value? Can you tell me why? Because we were using a reference, okay? That's why we can do it. If we're not using reference, we cannot do that, okay? But if we are using a reference, that we have a direct access to this data, and we can change its value. But if we were returning another value, basically, which is not a reference, we are returning a copy. We can change the copy, but we cannot access the original data. But with reference, we can do it. That's why we emphasize it several times that we are dealing with references here. And this guy changes the first character. Is this clear? Okay. Now let's go to this part. So we are printing forward and backward. Then we define string 1 and string 2. Last element, first element. We add string 1 to the beginning, and we add string S to the end. We print the list in forward and backwards. Then what do we do is in this data list, you see, I'm adding XYZ in the end, plus equal XYZ. Okay, and then I'm printing the list in forward, and we will see that these changes are visible. Why? Because we're using references. Then I'm setting my first character of my list to be 0. I'm printing and I can see the changes. But in order to see it better, just let's compile and run the code, and it will be more obvious, and you can have your break. So CS204 is an awesome course. Now let's go line by line and see what are we doing here. Up until now it's clear. So up until now we added the elements, those elements here. And now we created my list, and we call the print forward function, and it's printing in forward. CS204 is an awesome course. Afterwards we're calling this function, and we get this output. Course awesome is because we are printing it in backward. We define a new element which is called last element, S. Then we define S1, first element. We add to the beginning S1, we add to the end S. We print in forward and in backward. And this is what we get after printing first element, last element. If this is in forward, in backward, last element, and in the end we have here first element. Okay, afterwards, what we do is the following. At the end of each element of the data list, and you remember data list was this array here that we defined in the beginning, we add x, y, z. Basically, we add x, y, z. So we have CS204, yes. We add x, y, z in the end here. We add x, y, z. And we add x, y, z, and so on. But we add it at the data list here, not at this list here, but at the array. However, although we added it there, when we print the function using print forward, you see what we get? First element was not changed. Why? Can you tell me? So we added first element also, but this was not changed. Can you tell me why? And the last element also. Can you tell me why? Any idea why? Because the first element and the last element were not part of the data list. They were separate strings. So this was string S, and this was string S1. Okay? And those referenced those guys, but not the data list. That's why the first element is not changed and the last one is not changed. Everything else is changed. CS204 XYZ is XYZ, and XYZ, awesome XYZ. Although we added it, I repeat it again, at the data list array. Afterwards, we set the first character, mildly 0, but we set it using this part here. Okay? We set everything here to be, the first character to be 0. And so on. Everything is 0. But we change this part here, not the data list. But since we are using references, the changes that we do here we will see in the array also. That's why. Well, after the change, after I add 0, you see I can see 0, first element, and so on. But when I print the array, printing the array, I can see the same changes here. So 0, 0, 0, 0, and so on. Okay? What do you think? You see the string S and S1 we added in the end and the beginning. If I change S and S1, those changes, are they going to be seen in this list or not? The doubly linked list or not? If I change this guy, is this change going to be seen here or not? What do you think? Yes or no? Come on, guys. So when I created this list, I'm always using references. Okay? And you remember I created this list using the addToEnd function. But the addToBeginning was doing the same thing. addToEnd and addToBeginning were using references. So here I declare a new string and I put it to be in the beginning. And I declare another string S1 and I put the value of this guy to be this node, the data info. So if I change S1, am I going to see the changes here or not? Yes or no? Yes, because it's a reference. If you don't believe me, we can do the following stuff. After changing the data list XYZ, I can say, okay, I'm going to end it, and I'm finished. I'll say S1 plus equal to something that makes no sense. And S is equal plus equal to blah blah. When I execute the code, although I change it S1 and S, the changes are visible also in the list. Okay, so you see, first element, then something that makes no sense, then last element, and blah blah blah. That can be seen when I'm printing the list. Any questions about this example? Yes or no? No? You can get like 3 to 4 minutes and we'll be back. of break.